Hello everyone, my name is Can Korkmaz and I'm studying Electrical and Electronics Engineering at Bilkent University. Today I will explain my Physics 101 lab project to you. First of all, my project was about calculating the moment of inertia for a cylindrical shaped object, and I did this by using conservation of energy. But how does it work? So I said that I used conservation of energy. But for me to use this, I did not include any of the work done by the non-conservative forces in my experiment. And because of this, I can now take the formula of conservation of energy as potential energy initial plus kinetic energy initial equals potential energy final plus kinetic energy final. We also know that kinetic energy initial is equal to zero because there is no initial velocity. And now we can write the formula as shown. But we still have four unknowns in this formula. And if we want to solve the equation and pull out to I, we must find these unknowns. We can calculate heights by using a ruler. But for final velocity, we cannot directly find it. But we can find the average velocity by the fact that average velocity is equal to displacement over time. I know the displacement because I marked the points over the slope. And I know the time from both counting the frames from the footage and the chronometer near the mechanism. And lastly, for the omega, we will use the fact that omega equals velocity over radius in non-sliding rolling motion. And if we are done with talking about the theoretical part, let's talk about the practical part. So let's start with the materials I used. I used a cylindrical shaped mass which weighs 100 grams. Then I used the inclined plane with 30 degrees of angle. And lastly, I used a high-speed camera to record the experiment. So let's see how the mechanism works. Well, that was too fast, wasn't it? So let's slow it down. So, from these results, we can easily compute the moment of inertia for this object and compare it with the theoretical moment of inertia. And this is how I did my experiment. Thanks for your time.